Alright, so we're starting off chapter 5 talking about special lines that are inside triangles. So today we're talking about altitudes and medians. Then we have a couple more videos from section 5.1 to add a couple more lines and kind of put them all together. So in altitude, take a look at the definition. A line drawn from any vertex of the triangle to the opposite side and it's perpendicular. Okay, you need to have that down. You need to have it memorized. And what we're really doing is we're taking a line from any vertex, and we're drawing it so they're perpendicular. I could draw it from A, I could draw it from B. Now I know my lines aren't perpendicular, but just let's pretend they are. And they're perpendicular because I'm marking that it's a right angle. So I say altitude, you would say perpendicular from vertex. So, can an altitude lie outside a triangle? Take a minute to think about it. See if you can picture a triangle where it would lay outside. And the answer is actually yes. Let's take, for instance, an isosceles triangle. That's not isosceles, that's an obtuse triangle. So let's get our triangle straight first. If I wanted to draw an altitude from this point up here in the corner, I want to be able to draw it so it's perpendicular to this one down here. But the problem is that one stops. Drawing that line right there is perpendicular. So altitudes are able to be outside the triangle as long as it's an obtuse angle. A median is the segment that connects the vertex of a triangle to the midpoint of the opposite side. So if I were to say midpoint or median, you would say vertex to midpoint. So from B, I'm going to find the midpoint over here, and I'm going to draw a line from B to M. Now I can do the same from A to BC, and from C to AB, but my picture would be a little messy if I did that. Can a median lie outside a triangle? Unlike the altitude, this one can't because it has to connect to a point that's inside the triangle. So as long as it's connecting to a point inside the triangle like the median is, it cannot be outside the triangle. So let's take a look at this. If I know BD is a median, what that tells me is that AD and DC are congruent. So I know AD is 6x plus 3, and I know DC is 7x minus 1. My goal is to find AC. Remember, let's circle that so we remember to actually go back and do it. Because it's a median, I know those are equal. Let's subtract 6x from both sides. And I'm going to add 1. So I get x is 4. Now what I have to do with 4 is I have to go back and I have to plug it into both of these because it's looking for AC, or I could plug it into 1 and double it. So if I plug in 4 right there, 7 times 4 is 28, minus 1 is 27. And because I'm looking for AC, which is the entire segment, 27 plus 27 gives me 54. So now let's look at this one. HK is an altitude. Think about what altitude tells you. Altitude tells you right angle. We know IK is x minus 9. We know KJ is x plus 8. And we know HKJ, this angle right here, is 3x plus 3. One thing that you can never do, let's circle IJ or put a box around it so that we remember to solve for it. One thing you can never do is set angles and sides equal to each other. I know they both have x, but you can never set angles and sides equal to each other. You can also not take x minus 9 set it equal to x plus 8. That's really common. The only time I would set those two equal is if this said median. So if altitude was actually a median, the sides would be equal. Altitude only tells me 90 degrees. So I'm going to take my angle, the only angle I know, and set that equal to 90. Subtract 3 from both sides. Get x's. That's not right. Let's try that again. 3x equals 87. So x is 29. Got ahead of myself there. Alright, now I'm going to take 29, and my goal is to find AJ, which is this entire segment. If I add those two together, that's 2x, and negative 9 plus 8 is minus 1. So I'm going to take my 2x minus 1, and I'm going to plug in this 29. So we get that IJ is 2 times 29, which is 58, minus 1, 57. Alright, triangle ABC has these coordinates, so let's go ahead and graph them. If you can, draw a quick sketch on your paper also so that you have a graph to follow along with. Graph point A, graph point B. Be sure you label them. It'll be real important as we're going through this. And here's point C. Let me get some straight lines going between those. Oh, that's not supposed to happen. Let's try that again. Let's get some lines. Those are a little too big. I swear I'll get this right at some point. Here we go. Alright, so here's triangle ABC. Took a little longer than I would have liked, but here's triangle ABC. We want to find the coordinates of D. So D is going to be somewhere on this triangle if CD is a median. Now the fact that CD is a median is telling me that it's starting from C and going across to somewhere over here. I could kind of guess on the graph, but I want to be exact. So in order to find the other point, I need to find the midpoint because a median connects C to the midpoint. Remember, midpoint follows this formula. We should have this memorized by now, but it couldn't hurt to write it again so you see it again. And I'm going to take my x from A and B, and then I'm going to take my y's from A and B. And when I do that, I get negative 1 over 2, and 1 plus 5 is 6, 6 over 2 is 3. So if I go over negative 1/2, up 1, 2, 3, I get a point D, and I want to connect. Let's change the color. Let's do blue just for fun. CD is a median. And what I know by doing that is that BD and AD are congruent.